Okay, so we've built all of the parts of the Trammel Toy, and the next step then is to do an assembly. And in this demo, I want to kind of go over some of the different types of constraints that we can use to put this together. First step then is to open a new assembly file in Inventor. And I'm going to bring in my base plate first. Makes sense that the base plate would be the first one brought in. We want that to be constrained to the origin or grounded to the origin. And we can check that that's happened because one, it won't move. There's a little pin on the browser that we can look at. And we can also right click and check, is there a check mark next to grounded? Okay, it is grounded, it's not going to move, which is what we want. Next thing I'm going to bring in would be the corner guide blocks. There are 4 of these. So I'll put one in each corner. And I'm going to use the mate and flush constraints to constrain the corner guide blocks to the base plate. So I'm taking the base of this object and constraining or mating those faces together, hitting apply. And then I can flush these edges together. Apply. Apply. Okay. It would be the same process for this one. This one's kind of rotated a little bit differently than the way that it'll actually end up being constrained. And if that bothers you, or if it helps you to kind of get it in somewhat the right orientation, then go ahead and do that using the free rotate. And then again, we're going to use mate to mate the bottom surface of the corner guide block with the top of the base plate. And then I use flush solutions to flush the edges. I'm not going to do the other 2. It's the same process as these, but I'm going to move on to the pins that are going to go in here and then the screws that we're going to use. So I'm going to find those. We're going to use the base pins. There'll be 2 per guide block. And then also the base socket head cap screws. And again, 2 per guide block. Now for these, rather than using mates, we're going to use the insert constraint, which would be a new one for us. So instead of selecting mate, going to select insert, which is the 4th option. And when I do insert, I select the 2 faces that I want aligned. Like I want this part of my cylinder and this hole aligned. And I'm going to switch the solution so that it goes down into the hole. So those faces are aligned and I hit apply. That's it, I'm done. So unlike the mate where I have to do 3 constraints to get it in place, when I use the insert, I only have to do 1. It will still rotate about that axis, but that's okay. So now that I have the settings that I want, it becomes pretty quick to repeat the process for the rest of these base pins that have to go in. Okay? It'll be the same thing for the base socket head cap screws. You really have to think about where I'm clicking, right? It doesn't necessarily make sense to click the base of this and the top of this, because right now it's for one upside down, and I can't get a solution that's going to put it in the way I want. So you have to think about the parts of the objects that will actually be aligned when I'm done, when you make your selection for the insert. So I'm going to select the top of this and the top of my opening, change it to an aligned solution, and hit apply. Right, so these settings, again, be used for each of the different screws. All right, so assuming that I had done that for all 4 of the corner guide blocks, I would get something that looks like this. I want to go over then the process for adding in the 2 slide blocks. Bring those onto my assembly. So the threaded, holding down shift so I can do both, and the regular slide block, bring those in. Notice that there are planes in the middle of these. I did that intentionally. I want to have a plane so that I can constrain this plane or have that as an option for the constraint so that I can place this along the base plate. The way to do that is if you simply double click on a part, and I want to add a plane, I can select the plane and then 2 adjacent faces, so like this face and then the opposite face. And what it does is it puts a plane directly in the center between those faces. And that's what I did for each of those 2 parts. Also notice that you can double click on a part and it takes it from being in the assembly to now I'm working as if I'm in a part file. Right? The ribbons change, it looks a little bit different. So I did that for both of the slide blocks. And we did this already when we demoed how to make the base plate. We wanted to mirror each of the holes, and so we added planes to do that. So I'm going to turn those back on so I can use that. So I double click on my base plate, I go back into the browser and right click on the work plane, and turn the visibility back on. So those features now come up here as an option. So I'm going to constrain one of these slide blocks. I want to mate this face with the top of base plate and apply. And then I want to mate the plane through this slide block and the plane through the base plate and hit apply. And I'm going to stop there. I don't want to fully constrain this because I want it to be able to move still along, in this case, the z-axis. We need this piece to be able to move. So only two constraints in this case. I'm going to repeat the process over here. This surface with the top of my base plate, and then this plane with the other plane, and apply. Again, two constraints. This piece still moves like we want it to do. I'm going to bring in the last couple pieces that need to be added to my object. I have the crank arm. There is also the arm pin, which is going to connect that to one of my slide blocks. There is the crank knob. And we're also going to bring in the other two screws, the arm socket screw and the knob socket screw. Bring those in together. So let's focus in on just getting the arm attached to each of the two slide blocks. The farther of the two holes that are the same, meaning the one that's not threaded, is going to go into the slide block that is threaded. And I'm going to use an insert for that. So I'm going to insert, again, this surface should align with this surface here, and I hit apply. Both of these still move, which is what we want. I'm going to repeat the process. I'm going to look underneath this time. Right? I want to insert between this and the top of the other slide block. Apply. And now these move together. I can use inserts to put the screws in and the one pin that's going to go in there. So let's start with the pin, the surface with here. I want it to go down inside, so I'm going to change the solution to align, hit apply. And then same thing between here. You know what, that's a bad selection. Let's select the base of the head of this screw because that's going to sit on top of the hole here. I'm going to change the solution back here and hit apply. Last thing then would be the knob. Again, F4, holding down F4 is my hotkey for the free orbit. Select that. Top here, apply, and then insert the screw that goes inside here, change the solution, and hit apply. So everything's fully constrained now. You should be able to check that these pieces move together. If you can't constrain something together, or it's not moving once you do, there's probably an error in one of the measurements of your parts, so you have to go back and check that. So finally, I know that in the last demo, we looked at how do I get this to move? And this is not necessarily required, but for those who are interested, we can add a drive constraint to get this piece to actually rotate. To do that, I need to first kind of lock down this piece with an angle constraint. So I want to set the angle of this crank arm to be equal to, or have a zero angle between this crank arm and the base plate. And to do that, I hit constrain, I select angle. I'm going to select this surface and the surface down here, and I want the first solution, which is a direct angle, which is going to be set to 0, and I hit OK. When I do that, this no longer moves. It's kind of locked into place. To get the thing to rotate or to animate, I'm going to what's called drive the constraint. So I'm going to drive this angle constraint, right-click on it, select drive. I'm going to show starting at 0 and ending, and the number is really up to you. I did 3600 because that would be 10 full revolutions of my crank arm. I can hit play, it's going to move. Okay. A couple other settings that I didn't mind that you might be interested in is I went to the View tab, changed this from a shaded view to a realistic view, turn on the shadows. You can make this perspective. Perspective is going to look more like an actual object, so you may want to do that. And again, go back to driving the constraint. It's going to be a little bit slower with all of these other extra features turned on because it's obviously a lot more processing that has to happen in order for the shadow and the things to look realistic. So our goal for the next 2 days then is to take each of the parts that we built and make our final assembly. Make sure that you save that assembly file so that next week we can go over the process for making the exploded view and putting the drawing sheets together with the parts list and with the balloons.